Welcome back, everyone. Thanks for coming. In the last lecture, I talked about the notion of causality, the notion of trying to really measure the true causal effect of a risk factor on an outcome, how it's tied to this idea of counterfactual outcomes. And then I linked that to this notion of measures of association, something empirical, something we can measure in a data set, and tried to argue that that measure of association could be used as an estimate of the true causal effect of a risk factor on an outcome when you don't have confounding and bias. Well, let's talk now about what these measures of association are. What are these measurements we can make in a data set, like the Framingham data set that you have, that we've been using in the homework exercises? Well, first let me say that what I'm going to be talking about now is relatively easy compared to what we talked about in the last sequence of lectures. Before talking about measures of association, we had a sequence of lectures where I talked about prevalence as an outcome measure, and then I talked about incidence as an outcome measure after that and introduced the notion of cumulative incidence and incidence rates. But before that, I mentioned that those are types of measurements that we do in epidemiology. Depending on the outcome, whether it's nominal, ordinal, continuous, we might be measuring proportions, risks, we might be measuring percentiles, medians, we might be measuring averages. Okay, and we talked a little bit about the different types of outcome measures we would have. That's really the hard part of measurement when it comes to epidemiology. The easy part, relatively easy, is developing measures of association. Because let's suppose I measured the incidence of coronary heart disease among smokers, and I measured the incidence of coronary heart disease among a different group of people, the non-smokers. And I gave you those two numbers, and I asked you to combine those two numbers into a single number, but with the stipulation that that single number had to be able to tell me which of those first original numbers I gave you was the largest one. Well, if you think about it, if I gave you two numbers and it let you do any calculation you wanted, you could add them together, you could subtract them, you could divide them, you could multiply them, you could take their logarithms, you could raise them to exponentials, any calculation you want. But if you want that calculation to end with one number, and from that one number be able to tell me whether the first number I gave you was bigger than or smaller than the second, there's only two options you have. You can either take a ratio of the two numbers, or you could take a difference of the two numbers. So if I gave you the incidence of heart disease among smokers and the incidence of heart disease among non-smokers, and you took their ratio, incidence of heart disease among smokers in the numerator, non-smokers in the denominator, if that ratio was bigger than 1, then the incidence rate would have had to be higher for the smokers. If that ratio is less than 1, incidence rates for the non-smokers would have to be the bigger one. If the ratio was equal to 1, then the two incidences would have to be the same. Same thing with the difference. If you subtracted the incidence of heart disease that the smokers had, from that you subtracted the incidence of heart disease of the non-smokers, and the difference was positive, well, that means the first number had to be bigger. If the difference was negative, the second number would have to be bigger. If the difference was equal to 0, the two numbers would have to be identical. So all we do as epidemiologists when we measure associations is we divide our data set up into groups. One group might be the smokers, one group might be the non-smokers. We then measure outcomes separately within each group. Incidence, prevalence, cumulative incidence, incidence rates, whatever our outcome measure might be. But to build our measure of association, at the end of the day, all we're going to do is either divide or subtract one of those outcome measures from the other. So that's the logic behind measures of association. We're going to compare outcomes in two groups of people, our smokers and our non-smokers, and we're going to combine those outcomes into a single measure of association, into a single number, either by taking ratios or taking differences. So for example, this is a slide we saw a few sequences before when I first started talking about measurement in epidemiology. Remember what I said is there are different types of outcomes we epidemiologists measure. We measure binary outcomes, we measure ordinal outcomes, we can measure continuous outcomes. We spent some time talking about the various ways you could quantify each of those outcomes. If your outcome was binary, you could report a proportion, or you could report an odds, or you could report the rate in which that outcome is developing over a period of time. If your outcome was ordinal, you could do the same thing. You could collapse an ordinal outcome, say, into a binary outcome and report proportions or odds or rates. But you could do one more thing that you couldn't do before. You could line people up against the wall by their ordinal outcome, say their quality of life. How do you feel? Excellent, very good, good, fair, poor. And find the person in that lineup and report his or her quality of life as the median, the middle quality of life in that group of people. And then finally, if you have a continuous outcome, like blood pressure, I said you can do everything we did before. You can categorize blood pressure and report the proportion of people who have hypertension. You could line people up against the wall according to their blood pressure measurement, find the person in the middle, and report the median blood pressure for that group of people. Or if you want, you could average the blood pressures before. And we talked about averages. Now remember my little baseball quote when we talked about averages. Averaging makes sense when you're averaging similar values together. Just remember that if half of your body is burning up because it's in a fire and half of your body is freezing over because it's in an ice bucket, the average might suggest you're doing fine. We'll talk more about averaging unlikes together when in a future sequence of lectures. But this is what we've done before. We talked about measuring these outcomes. Now to measure associations between risk factors and outcomes, all we're going to do is take ratios or differences. So if we're measuring proportions of people who get disease, cumulative incidence, we talked about cumulative incidence being an estimated risk. So if you divide one cumulative incidence by another, you come up with something called a risk ratio. If you subtract the two risks, you get something called a risk difference. If you turn those risks into odds and take the ratio of the odds, you'll calculate an odds ratio. If you take if you measure incidence rates rather than cumulative incidence and take their ratios, you get a rate ratio, and if you take the differences, you get a rate difference. I'll give you examples of these in the next lecture. And you'll be doing calculations either in Stata or by hand just to become familiar with this. Same thing can be true for other types of outcomes. You can take ratios or differences of medians, ratios or differences of averages. But let's focus on the binary outcome, as we've done so far. Let's focus on outcomes like dead or alive, coronary heart disease development, or non-coronary heart disease, or coronary heart disease non-development. And if you have a binary risk factor like smoking and a binary outcome like death or coronary heart disease, you can display your data in what we call a 2x2 table. It has two rows, one representing the exposed people, those could be the smokers, one representing the non-exposed people, those could be the non-smokers. So each row represents a subset of your data set. You have in this table N1 people who are smokers in your study. You follow them over time to see who develops some outcome. Say the outcome is death. A people die. These are the people who developed death. And B people survived. You can estimate the risk of dying for a smoker by its cumulative incidence. You could take the number of deaths, A, divided by the number of smokers you have, N1, and that would be the cumulative incidence or the estimated risk of death among the smokers. You can do the same thing for the non-smokers. C people die and D people don't die. Their estimated risk, their cumulative incidence is C over N0. To build your association, all you're going to do is take the ratio or the differences of those numbers in that last column. So we can define a risk ratio as the estimated risk among the exposed people divided by the estimated risk among the non-exposed people, R sub 1 divided by R sub 0, where R sub 1 is the estimated risk among smokers, R sub 0 is the estimated risk among non-smokers. You could take the difference of those two estimated risks to come up with what we call the risk difference. Or if you wanted to, you could turn those risks, the smokers' risks and the non-smokers' risks, into odds, take the ratio of those odds and get something called an odds ratio. So the odds ratio is the odds of getting coronary heart disease among the smokers. Remember, odds is nothing more than risk divided by 1 minus risk, divided by the odds of disease among the non-smokers, R0 divided by 1 minus R0. Those are the formulas we use to calculate those commonly used measures of association. So let's use an example to show you how this all fits together. Let's use the example I made up and presented to you in the previous sequence of lectures. Let's imagine I contacted 100 of you by email or called you up and decided to follow you for the first 7 days of this course to see how many of you guys developed headaches. This is an example we talked about in the previous sequence of lectures. What we had were 100 students being followed for 7 days until one of two things happened. Either they developed their first headache or 7 days passed. There are no losses to follow-up, no losses due to competing risks. This is the data we saw before. 4 people developed headaches on the first day, 1 other person developed it on the second day, etc. And then the last column is the same thing we had before. These are the amounts of person days that each person was followed, either until they developed a headache or until the study ended, which was 7 days after it began. Let's suppose when I called you up and enrolled you in this study and followed you for the next 7 days, I also recorded other pieces of information about you. And one of the pieces I recorded is whether you're a male or a female. So what I could do is break these data down into 2 groups. The data describing the incidence of headaches among the males in my study and the data describing the incidence of headaches among the females. Let's suppose it just turns out that there were 50 men and 50 women in this study. The black ink corresponds to the 50 men who are in our study of our 100 students. And notice, if we look at the 50 men, it includes the 4 people who developed headaches on the first day, the person who developed headaches on the second day. What I have over here in black are the amounts of person time contributed by the men in this study. So for the time being, ignore the red, as if it weren't there. And what we'd have in the black ink is the number of cases and the days they developed headaches among the 50 men in our study. The next slide, we'll be focusing just on the red part of this slide, just the 50 women in our study. And we see that some of them developed disease, a grand total of 5 of them did. And we have in red is how many person time was being followed for each of those 50 women in our study. Now we can add the number of cases, the number of non-cases, the number of person time, and summarize these results in tables. So here is a 2x2 table display of what was shown in the previous 2 figures. The top row is representing what was in the black ink before, the outcomes, the follow-up of the 50 men. The second row is what was in the red before, the outcome, the follow-up of the 50 women. So what do we see here? We had 50 men in our study who were followed for up to 7 days, and 10 of them developed headaches. So the cumulative incidence, the estimated risk of developing a headache among a male in your study is 10 over 50 or 20%. Among the women, the red ink on the previous slides, there were 50 women. Only 5 of them developed headaches, so their cumulative incidence is 5 over 50 or 10%. From those 2 outcome measures, we can develop a measure of association. For example, we can calculate the risk ratio, which is the ratio of the estimated risk among the men divided by the estimated risk among the women. The 10 over 50 among men divided by the 5 over 50 among women. That's 20% divided by 10%. It's a ratio of 2.0. How do we interpret that? We say the risk of developing headache for a male student in this class is twice that of a female. It's 2 times higher. So a ratio measure gives us a measure of how much you have to multiply the outcome in the non-exposed group, the females, to obtain the outcome in the exposed group, the males. An alternative would be take a difference in those outcomes, calculate a risk difference. Take the risk, the estimated risk among the men, 20%, subtract from that the estimated risk among the women, 10%. We get a risk difference of 10%. How do we interpret that? We say that the male risk of developing a headache is 10 percentage points higher than that of a woman. That's how many percentage points you have to add to the risk of a woman to get the risk of a male. Well, that's if we looked at cumulative incidence data. Well, an alternative is to look at the incidence rate data to take into account how much time each of the 100 students was followed in this study. We had 50 men in this study. If we count each male's number of person days of observation, we would observe 302 person days of observation, from which 10 cases of headaches occurred. So the incidence rates of developing a headache among the men in this study would be 10 divided by 302 person days. For the women, We would observe 343 person days. Out of that, 5 women developed headaches. The incidence rates for women, for females in the study, would be 5 over 334 person days. Once again, once we have these outcome measurements, these incidence rates, we can develop a measure of association by either taking the ratio of those two incidence rates, dividing the 10 cases out of 302 person days that we saw among the men by the 5 out of 343 person days that we saw in the women, coming up with a ratio measure 2.27. And the way we interpret that is we say the incidence rates for developing headaches for men in the class is 2.27 times that of the women. It's what we have to multiply the incidence rates for the non-exposed group to get the incidence rate for the exposed group. Alternatively, we could take a difference in the incidence rates. Take the incidence rates among men, 10 over 302 person days of the incidence rates, minus the incidence rate now of women, 5 over 343 person days. If we do that, the 10 divided by 302 person days incidence rate for men is the same as 3.31 headaches for every 100 person days of follow-up for men. The 5 divided by 334 person days of women is the same as 1.46 cases of headaches for every 100 women person days of follow-up. So the rate difference would be the 3.31 minus 1.46, or 1.85 extra cases of headaches for every 100 person days of follow-up. So notice the rate difference is not a pure number. It has a measurement, a time measurement in its denominator, person days, because what it's reflecting is a difference of 2 incidence rates. Each of those have time in their denominator. So this is how you can calculate measures of association from incidence data using either cumulative incidence or using incidence rates. The next time we come back, I'll talk about measuring odds ratios when we have data like this. So see you next time.